This video is going to work through questions 21 to 30 in the review exercises for the midterm. Here we have x and y that are discrete random variables with the joint probability mass function given in the table below. We want to find the value of c. The thing to realize is that all of the probabilities in the joint PMF need to sum to 1. And so if I add all of these up, I have 1/20th plus 2/20ths plus 1/20th plus 0 plus 0 plus c plus 2/20ths plus 1/20th plus 1/20th plus 2/20ths plus 4/20ths plus 2/20ths. All of these have to add to 1, and so that means that c has to be 4/20ths. Okay, so once we have c, and I'll just write it in here, it's 4/20ths, we're going to find the marginal distribution of x. So for each of the possible values of x, I'm going to find the probability that x takes on the value little x. So I know the possible values of x are -2, 0, and 2. And to find the marginal probabilities, I'm just going to add across the probability that x is equal to -2 and y equals 0 is 1/20th, plus the probability that x is equal to -2 and y is equal to 1 is 1/20th, plus 1/20th plus 0 gives me 1, 2, 4/20ths is the probability that x is equal to -2. Similarly here I've got 4/20ths plus 2/20ths plus 1/20th gives me 7/20ths is the probability that x is equal to 0. And finally 1 plus 2 plus 4 plus 2 is 9/20ths is the probability that x equals 2. And I should always do a double check that these sum to 1, and they do. The marginal distribution of y, I'm going to do the same basic thing, but this time for each of the possibility values of y, I'm finding the probability that y takes that value. So my possible values are 0, 1, 2, and 3. And the probability that y equals 0 is 1/20th plus 1/20th is 2/20ths. The probability that y equals 1 is 2/20ths plus 4/20ths plus 2/20ths is 8/20ths. The probability that y equals 2 is 1/20th plus 2/20ths plus 4/20ths gives me 7/20ths. And the probability that y equals 3 is 1/20th plus 2/20ths is 3/20ths. And again, I should double check. 8 plus 2 plus 7 plus 3 is 20/20ths. That sums to 1, so that's a valid marginal distribution. Okay. Next thing I'm going to do is find the conditional distribution of x if y is equal to 2. So I'm saying, okay, for each value of x, I'm trying to figure out g of x given that y is equal to 2. To do this, remember g of x given y is equal to f of xy, the joint probability that x is equal to x and y is equal to y, divided by the marginal probability that y is equal to little y. So for this situation where y is equal to 2, this is going to be f of x2 divided by the marginal probability that y is equal to 2 is 7/20ths. So for x equal to -2, okay, -2 and y equals 2 is 1/20th divided by 7/20th gives me 1/7. For 0, probably that x is equal to 0 and y is equal to 2 is 2/20 divided by that marginal probability, 7/20, gives me 2/7. And finally, for x equal to 2, the probability that x is 2 and y equals 2 is 4/20 divided by the marginal probability, 7/20, gives me 4/7. And again, I need to double check. 4/7 plus 2/7 plus 1/7 equals 1. So this is a valid conditional distribution. As I find the conditional distribution of y if x is equal to -2. So here, for all the values of y, I'm finding h of y given x equals -2. And to do that, h of y given x, remember, is the joint probability that x is equal to x and y is equal to y, divided by the marginal probability that x is equal to little x. In this case, because I'm using -2 in place of x, this is going to be the joint probability that x is equal to -2 and y is equal to y, divided by the marginal probability that x is equal to -2, which we saw was 4/20. So y can take the values 0, 1, 2, and 3. The probability that y is equal to 0 and x is -2 is 1/20. We're going to divide that by the marginal probability that x is -2, which is 4/20. So that gives us 1/4. -2 and 1 gives us 2/20 over 4/20, which is 2/4 or 1/2. For 2, the joint probability that x is -2 and y is 2 is 1/20 divided by the marginal probability that x is -2, 4/20, gives us 1/4. And the joint probability that x is -2 and y is 3 is 0, divided by 4/20 gives us 0. And once again, 1/4 plus 2/4 plus 1/4 sum to 1, so that looks good. Okay, so next we're going to find the mean of x. To find the mean of x, I'm only interested in x, so I'm going to use the marginal distribution of x. So the mean of x I'm going to find by adding up, for all the values in the space of x times the marginal probability that x takes on that value, little x. So here I have -2 times 4/20 plus 0 times 7/20 plus 2 times 9/20. Again, I'm finding the mean of this marginal distribution. And that gives me 10/20 or 0.5. For question 27, I'm trying to find the expected value of x if y is equal to 2. So here I'm using the conditional distribution. So my expected value of x given y is equal to 2. I'm going to take by, again, I'm going to sum over all the different values of x that are in the space of x. X now times this conditional probability, g of x given y equals 2, y, the random variable, equals 2. So I'm using this conditional distribution if y equals 2. So I have negative 2 times 1/7 plus 0 times 2/7 plus 2 times 4/7, which gives me 6/7. And now we've got just a few more quick questions in this set. So for each of these, we're trying to answer a question and think about which distribution is appropriate to use. So here I'm interested in the probability that x is equal to negative 2. Since this is a question only about probability associated with x, I'm going to use the marginal distribution of x. I'm going to find the marginal probability that x is equal to negative 2, which, coming up and looking at my marginal distribution of x, I can see is 4/20. If I am looking for the probability that x is negative 2 and y is 2, here there's no if type of statement, so it's not conditional. This would be one that I'm just looking for the intersection, and so I'm going to use the joint distribution. F of negative 2, 2. So negative 2 and 2 gives me 1/20. And then finally, if x equals negative 2. So when I have an if statement, I know this is conditional. And I'm interested in probabilities associated with y. So what I'm interested in is h of y given that x is equal to negative 2. That's the distribution I'm going to use. And in particular, to answer this question, I need to find the probability that y is equal to 2, given that x is equal to negative 2. So looking at my conditional distribution of y, given that x is equal to negative 2, 2 gives me 1/4. So there are my answers to those. So again, just as we're looking at these distributions, if I'm looking for the probability of an intersection of events, I use the joint distribution. If I'm looking for answering a question related to only the random variable x, then I use the marginal distribution of x. If I'm answering a question that's only about the random variable y, I use the marginal distribution of y. If I'm answering a question that's saying, like, if y equals a particular value, then I'd be using a conditional distribution of x given y. And if I'm answering a question that says something along the lines of, if x equals a particular value, what is a probability or a mean associated with y, then I would use this conditional distribution of y given x. Thank you.